Hey pioneers, and welcome back. Today we will keep on working on this nuclear power plant. It's been already 2 videos. I think it's by far the biggest project I've made, and hopefully we finish on this one. The thing is that I talk too much. I need to know when to shut up and not talk nonsense, like I'm doing now. So let's try to stay focused on what we have to do. So what are we missing? We've done, the diagram is looking ugly, but everything that's outside is what has been done, and we are only missing the machines that are radioactive, and the idea is to place them inside this structure I made. Now, when I planned this, I planned to place machines on the roof. It has a specific size to fit some particle accelerators and shenanigans, but the thing is that this whole room is huge, and I think I ended up having more space than I need, so I have no clue. If I could place everything inside, that would be ideal, but if I can't fit everything, I don't want to place 2 machines in the roof, so I will be juggling with that. The biggest machines I have are refineries that can easily fit, and particle accelerators that can also easily fit over here. So, I don't know, I'll do some tests and we'll wing it. What's the worst that could happen? Okay, so for the time being there's no logistics, there's nothing. I want to see if the machines fit. So, well, I started by the biggest ones. This is the last segment. 10 particle accelerators and 10 assemblers. They fit over here on one wing. There's still a lot of extra room. I mean, I could add a second floor. But for the time being, let's assume I'll leave it there. I don't know, we are trying stuff out. So what are the biggest machines after these ones? I think this module, refineries and blenders. That I hadn't read this properly because I did something similar, a closed loop with aluminum. But in that case, it was a 1-to-1 ratio. Here we have 1-to-3. Because this would be 15 blenders and this would be 5 refineries. So it's going to be a little bit hard. The idea is that this won't be connected to any water. We initialize the system once we fill this pipe over here with water, and then that will give us the sulfuric acid, that will give us the water, that will give us the sulfuric acid. So it won't be connected to anything. It would be an independent system. But well, we have weird ratios and I have to figure out how to do it, so now I will try to fit these machines. And here we go. I know I said I wasn't going to place any logistics, but the thing about this module is that it was never planned for the roof. Even if I can't fit all of the machines in here, this will stay in this place. These machines can't go in the roof. So I placed some of the logistics, not all of them. And I know, it looks like a noodle factory, but I did it as organized as I could, and I want to state something so that it's clear. I'm over-exaggerating. I always over-exaggerate with fluid dynamics because I rather prevent issues than have to troubleshoot them. So maybe most of the stuff I did here wasn't absolutely necessary, but well, that's me. I overcomplicate things. So what can we see? In general, there's always 1 refinery in front of 3 blenders. So this would be one group, that would be another group, we have another over here, and on the end we have 2 of these groups. They are all the same, so we can only analyze one, the rest are a copy and paste that I couldn't blueprint. This was all manually built, but well, stuff that I do when I'm a weirdo. We start by a refinery that's producing sulfuric acid, and this sulfuric acid has to go to 3 blenders. As I don't want to have any issues, I'm using the water tower principle, so I'm actually pumping the sulfur higher, and then this sulfur falls into this junction to be spread onto the 3 blenders. Now, what's the idea of this? We will start having sulfur over here. And as we have a pump, it can reach this higher place. And then it will fall and it will stay trapped in this segment I'm highlighting because it will never try to climb up if it has lower places to go. So all of the sulfuric acid that is on this segment of pipe will be applying pressure and will wanting to go to these 3 pipes. So maybe this one isn't filled up, this one isn't filled up, but we know that these 3 pipes will, because they have a whole column of sulfuric acid making strength, making force to go downwards, to go down. I shouldn't use strange words if I don't know what they mean. On the other side, we have the water byproduct that again, I'm doing the same thing. I'm pumping it higher. So each one of these pipes will bring the water byproduct. And then we follow the same principle. They all fall into this pipe over here. So it will be kind of trapped over here and they will try to go that way. And this way is the water input, because these refineries need 44.52 water, and each one of these blenders have 14.84. If we do 14.84 times 3 is our 44.52. So this is the closed loop. All of the sulfuric acid gets divided into these 3 blenders, which produce water that gets merged into the refinery. So you might wonder, how do you start up the system? Because you need something to start with. And that's where this crazy platform comes into place. What do we have here? We have 2 industrial storage containers connected by a lift. Here is where I will be dumping packaged water. And it gets equally spread between these 3 that are unpackaging water. And all of the canisters get merged and sent to these other containers. So I dumped packaged water there, I get empty canisters there, and this pipe will be filled up with water. And again, I'm playing with the heights, so all of this water will fall into this big circle that goes all around this place. And this big circle is always connected to one of the 3 pipes. So this one is connected to this group, this one is connected to that group, that one is connected to this group, to that group, and we have the last one over there. So as we have height differences, the water will be able to go down over this pipe, and will also be able to fill this one, because it's coming from a higher place. This is way higher than all of these pipes. So I'm not sure how much packaged water I will have to dump. Probably a lot, because there's a lot of pipes. But eventually all of this system will be initialized and will have a lot of water, so the systems will be able to start. I just need to remember to throw some packaged water. And this was hard to me. I was about not to do it, because what's the deal? Right now we have these pipes that they are absolutely filled up with water, and there are water extractors connected on the other side. So I could have easily placed simply a junction over there and a junction over here and temporarily do that connection, and everything would be filled up. But I want to build... This is only me. I'm kind of a weirdo. I like building the factories complete. It must be able to do everything that it needs to, and starting up is one of the things. I don't want to have to build something and then dismantle just to start up the factory. Truth is, these 3 unpackagers will be only used once, and they will be there decorating. But I feel like it's the right way to go. So right now I was able to fit all of these, and we actually have a little bit of spare room on this wing. I think we will be able to fit all of the machines. Still, there's a lot of logistics to be added over here, because we need the nitric acid. That means even more pipes. And well, we need to connect the waste, the silica, all of that crap will come over here. These refineries need sulfur. So yeah, this is like 1/3 of the total logistics. But first I wanted to know if it was possible to fit all of this. Pipes are harder to work with than belts. If I could fit all of the pipes, I will be able to fit the belts. So I think that this part of the factory will remain like that. Maybe we switch some machines to the roof, but I'm glad with this result. So let's go on. And the last machines we were missing were 40 manufacturers, and they easily fit. So I think I can start taking this up seriously. Oh, that shouldn't be there. And start wiring all up, placing all of the logistics. Then connecting the inputs. I need to add some rocket fuel for my drone. And well, there's some more stuff that I need to add, like a sink, some dimensional depots, but what's left is not that much. And I still have a lot of space here in the middle. I have no clue what I'll have to do here. I'm also not liking how the pipes look, but I think I can't hide it. Can I? I don't know. But well, let's play some logistics. And that took longer than expected, but I'm loving how it's looking. I think this is by far the best project I made. So I won't break down all of the logistics. It's basically balancers, splitters, and some mergers. But well, let's make an overall description of what I made. For example, I'm not doing logistics floors, I'm doing logistic roofs. I added these structures and all of the belts and pipes are handled on top. And most of them end up doing loops at the end of each of these wings. So I think the result is pretty interesting. Now, when I set up the pipey module, I didn't realize that this requires nitric acid, and the nitric acid is being crafted over there, so I should have placed it here. But well, mistakes were made, and now I have one pipe going all around the factory up to where it ends. But well, it wasn't that bad. Regarding these balancers, I took some time to calculate the amount of materials we have on each one of them and always placed the slowest belt possible. So I think it's going to end up looking really nice. There are plenty of these that are actually full but not saturated, meaning you will always be seeing materials over there, not a single gap, but it will never stop. I think that's pretty awesome. Now, most of the inputs come from this place, most because I'm grabbing silica right where I'm crafting it, and some sulfur comes from that side. But over here we have our sushi belt. So we have here on the middle, we have our sushi belt. The two on the sides are the belts that have a lot of quick wire, and well, the rocket fuel for the drone goes on top. Over here we have a programmable splitter dividing all of these materials. I added a new one, sulfur. And in total, right here, we have 418 materials per minute. And before that split that we are doing, we end up having 10 different materials at 700 per minute. So that's going to end up looking really good, I think. Now, what else can we tell? I've been working so far that I don't remember. Well, machines, I miscalculated a little bit because I always took the least amount of machines possible. For example, 20 manufacturers or 10 particle accelerators. But we have a lot of belts that are almost at full capacity. And if they are at full capacity, you can do a balancer with feedback. So I had to add some extra machines. Now we have 12 particle accelerators, meaning no feedback, and I had to add that one and that one over there. And over here I also took it from 10 manufacturers each side to 12, because there was one material that was too close to full capacity. These ones, for example, remained the same way. We can see that this division over here, that's the feedback. And, well, it's looking pretty good. The uranium and the rocket fuel are being sent to the roof through the middle of these pipes over there. So I don't know how I'm going to decorate this, and I don't know what I'm going to do with these pipes. I'm assuming that maybe when 1.1 releases, I could dismantle these two, and if I do it curved, it might look way better. But well, for the time being, this is what I've got. Now, what was the biggest challenge of doing this? This building is cursed, and I really mean it, it's cursed. Let's place a lift. So far so good. Let's place a splitter on top of it. As you can see, I can only choose between left and right. The middle input is not working. I don't know why I've never seen this bug on my life, but well, I'm limited to only 2 directions. If we do the same thing outside, it actually works on the 3 sides. How on earth do these things happen? I have no clue. So how I worked around that, it was pretty annoying, but if I wanted to use the middle output, I had to first place a splitter, then place one on top, remove the bottom one, place one on the bottom in the correct direction, then remove the lift, and I had to recreate it, but to keep the alignment, it needs to be a compact lift. So I had to first place the support, and then the lift, and there we go, I created it. Yeah, that wasn't fun, but well, yeah. I had to fix it, so that was the only way of doing it. So, well, other challenge was balancing the nuclear reactors, because we have 5 on each side. That already is a balancer with feedback, and they are spread all over the place. I couldn't think of a tidy way of doing it. I tried several approaches. I think that this one is pretty decent. Here we can see that this is the feedback loop for each side, because I'm actually dividing into 6. This is 1, this is 2, and this is the 3rd one. And well, the inputs are on the end of each wing. And there's a, well, this is the last one. There's a tiny balancer on feeding each one of these 4 wings. And I'm assuming that I later on can support it somewhere, something like that. Yeah, it looks decent. But that's for the decoration phase. We are far away from that. So, yes, I think that's most of the stuff. Maybe I'm forgetting some things. Here we have the output management for different materials. I did the silly thing I've been doing. For example, this, as it's an lonely manufacturer, this is doing the nuke novelisks. And everything is balanced. I'm only feeding 1 input belt. So this is a sushi stuff. And yes, I have no idea what I'll be doing here in the middle. We have a lot of space and I had to do something cool, but I honestly have no clue. So, well, I'll have to think about that. But this is looking pretty dope. I'm really happy. So what's the next step? I need to connect every single machine to the power grid. We are talking about around 200 machines. That's going to be a nightmare. And after that, I'll turn it on, check if everything is working. Probably not, because the size of this factory, I'm bound to have made 1 or 2 mistakes, or 14. And if I get everything working, well, then I'll move to the decoration phase, that it's also going to take a lot. But well, one step at a time, let's connect everything to the power grid and start this bad boy. Well, there was a slight change of plans. I wanted to showcase the finished power plant, but what happened? I had a 2 weeks holiday. I flew back to Argentina, and that means 2 weeks not playing Satisfactory. And when I got back, I just found out that my job is flying me to Germany, that it's pretty cool. I never had a job that flew you abroad. But well, that's also going to be 2 weeks without playing the game. And if I didn't upload a video, that would mean not uploading anything for a month. And I don't think that's good for the channel. So I decided to show where I got to, because I need to be taking a plane in a couple of days. And we are actually almost there. The factory is already working, 100% efficiency, and I've done most of the decorations. I'm only missing this building, but all of the rest has been done. And I already started with this building. You can see that there's a fancy roof over there. Regarding efficiency, it's been working for several hours at 100 non-stop. Check this beauty. That's a lot of power. And well, we can see 193 gigawatts, but that's not all of it, because I spread it between my 2 grids, the stable and the unstable one. So 1/4 of the nuclear reactors are in my unstable power grid. I can rearrange them. If I need more power over here, I can just switch the connections. So yeah, we are online. This has been by far the biggest project I've made. It's like 200 or 300 machines spread all over the desert, but it works. Now, not going to be able to showcase the whole factory, and this video might end up being short. Well, I don't know, they are never short. I'll do something different. I want to talk about the issues I faced and how I troubleshoot them, because I play a weird way. Most of the pioneers start turning on the machines as they build it, and this is a really good practice. I don't do that because I enjoy seeing how everything starts up. So I build everything and then turn it on all together. That means that there are a lot of things that can go wrong, especially with a factory of this size. So let's start describing some of the issues I faced. So one issue was the uranium. We are having 480 delivered via a drone, and I connected it with an MK5 belt to my manufacturers. So even though the materials come in bursts, we will be receiving more than we need at one moment, and we won't be receiving any for some time. As we have MK5 belts, this should have worked because the extra we receive at one point ends in the internal buffers, and that feeds the machines when there's no uranium. But that didn't work because of another thing I made that I didn't thought about it. If we check here our manufacturers, you can see that I always went for the slowest belt I could because I like how it looks. And what happens? Each of these manufacturers require exactly 20 uranium, and we are in groups of 3. These 3 manufacturers I'm highlighting get fed by this belt over here, which is an MK1. So we need 3 manufacturers that need 60 fed by a belt that only has 60. That means that this internal buffer that we see here is as it doesn't even exist. It will never get filled up. The only way of filling it up is if we are missing another material. But we have no buffers, so the extra uranium we are getting, we can't store it anywhere. And I was having issues with uranium. Obviously, this is extremely easy to fix. I just had to place a container over there. It's connected with MK5 from the drone, and after that it goes to an MK4. So if we follow that MK4 belt, that should be somewhere around here, we can see that it's always saturated. So yeah, that was an unexpected issue, but it wasn't that bad. Another self-inflicted problem I had was with sushi belts. This is the most critical part of the factory. Over here we have 11 different materials running at, I think, 760 per minute. So what happens? All of these materials are not used at the same time. For example, the sulfur that we see, the sulfur is needed to process the industrial garbage, and it takes a long time until we make the uranium fuel rods, they go to the power plants, and the garbage comes out of it. So what happened? Well, the sulfur started piling up, and it jammed the sushi line. And well, it wasn't only the sulfur. It was getting jammed at many places. And as I'm working with the slowest belts I can, you usually would go to the machine and clear the buffers. But if the buffers never get filled up, it's a pain. You have to actually remove the items from the sushi belt. So I fixed that by adding fail-safes. For example, right over here, these casings come from that sushi belt and go to these 4 blenders. And well, what happens if this gets filled up? I added a smart splitter, and it would be sending the overflow right there to that industrial storage container. That's currently empty. Yes, of course, placing a sink would have been the smart idea, but I didn't have any sink nearby. And if you place a sink and don't use it, your max consumption won't be equal to your consumption, and that triggers me. So yeah, maybe this is not the best thing, but it works. Any jam, it will start sending them that way. Here we have another failsafe. These are the casings that are used inside the power plant, and well, there's another smart splitter that's sending the overflow to that sink, now a real sink. So if by any reasons these guys don't start working immediately, it will get sunk and it won't jam the sushi line. And we also have another one over here, because after this guy, we only have sulfur. And if the sulfur jams, we have another smart splitter sending it that way. So all of these, once the system works, they will never be used. But yeah, it helped me starting it up because it was a nightmare. I couldn't get the power plant on because all of the sushi bolts were exploding. Fluid dynamics were a mess. And this really surprised me because I wasn't expecting these problems. Over here, this is the module that's doing our rubber that I never meant to do, but I ran out of rubber. And what's the deal? This whole segment uses 300 oil per minute. And it's connected with an MK2 pipe that has capacity for 600. So I assumed that if it's only used at 50%, it should work, right? Well, it didn't. They were all working at 97, 98, and it was extremely hard to fix. The first thing I made is this module over here that we see. Oh, I messed up. We see 6 refineries. I had 5. I added 1 and underclocked them. And why is that? Because let's assume these are the pipes. How had I done the 5 refineries? It was something like this. So this is the shapes the pipe had, and what I found out is that the refinery that was over here was getting prioritized over these 4, which makes sense because the oil was only falling over here. It wasn't going that side to the other sides. So by adding, I'm messing up. By adding 1 extra refinery, I could make a symmetrical design, and that improved stuff, but it still didn't work. Another issue I found is that the left side was working at less efficiency than the right side. That was easy to fix. It was only because this junction wasn't exactly in the middle. It was a little bit closer to that side, which make this length shorter, and these refineries were prioritized. But still, I had issues. Still not working at 100%. The last thing I made that did the trick was adding these buffers. I added 1 over here next to the load and 1 next to the oil extractor. This is from the other side. This is the new buffer. So why did this fix the issue? What was happening? I don't know if we'll be able to see it. Yes, we can. What I was saying is that the pipe was sometimes going at 600 and sometimes going at 0. Like we can see right here, 0. So it was going from 0 to 600, 0 to 600. The average is 300, so everything would be fine. But what's the issue? The issue is over here in the water extractor. This buffer is extremely small and gets filled up really fast. So if the time we are getting 0 flow on the pipe is long enough, this will get absolutely filled up and the machine will stop. By adding a buffer over here, we are basically increasing the size of that buffer, so the machine will never stop. And if this starts getting filled up, it will apply more pressure onto the pipe and it will be easier for it to flow. So yeah, this fixed everything, and it's always around the same level. So I'm guessing that this amount of oil we see over here, that was the amount of pressure the system was needing to be able to work non-stop. So if this machine never stops, if this buffer never gets filled up, the refineries on the other side will be working at 100% because it's a closed system. The oil can't go anywhere. If we are extracting everything that we need, it will get to the other side. Then, if we talk about water, I didn't have any issue with the water that actually goes to the nuclear power plants, but I did have with the water required for the rest of the factory. I'm currently using 3 pipes. One that's at 74% capacity. This one didn't have any issue at all. Then we have another pipe that's at 66% capacity, also no issue at all. But this one, that's the one that has more water, 87.82, this one was also having issues. That water extractor was working at 97%. So I made the same principle. I just added some small buffers over here. I didn't add them on the load, I only added them here. And this worked. It stabilized everything just by increasing the buffer size. So it's always around that level, and since I done that, it's working at 100% non-stop. This buffer never gets full. Those were the main issues I faced. but still there were tons of tiny errors, like bells of the incorrect speed or something that hadn't snapped into the correct place. And how do you fix those? Because I've never made a factory of this size. We have over here our main power plant. Over here we have a lot of machines. We are taking water from this place. We are taking more water from this place. We are taking some oil from around here. So you can't go machine by machine and inspect them and say, oh, is this working at 100% or not? Because it would take ages. And well, there were still some errors. So what I made might sound silly, but it actually helped a lot. I completed even more my spreadsheet. What we see over here, these are every machine that makes our power plant. And there's a total of 460 machines. And well, what I note is the amount of machines and the consumption. And this is ordered by consumption. So we have ones that consumes 56.6 megawatts, another one that consumes 4.6. Doing this took some time, but it actually saved a lot. Because once you've got that, you can simply, let me find some power. Maybe over here. Yes, you can, if you see an oscillation, you calculate the difference and you can realize, oh, there's a fluctuation of 13.2 megawatts. So then I go to the spreadsheet and I see if there's something that consumed 13.2. Well, in this case, there isn't. But well, if it was 13.5, I would know that it's one foundry that's doing steel pipes for my modular frames. So yeah, it was a lot of time of documenting, but once I made this, I could easily find exactly which machines were underperforming and fixing whatever I had to fix. And with that, we wrap up today's video. We have a power plant working and we have infinite power, which is really good. So next video will probably come in a couple of weeks, like 2 or 3, because I'm getting in a plane tomorrow, I think, or the day after tomorrow. And well, I will finish this power plant and probably do a short video just showcasing the decorations. I'm sorry for that, but well, that's life. I will be on Munich, so if there's any pioneer that lives in Munich, I will be 2 weeks there. We can have some beers. I hope you guys had fun, and I'll see you on the next one.